Good morning, Calculus AB. How's everyone doing? Happy Friday. Go ahead, guys. If you're here, let me know in the chat so I know who's working today. I applaud you for waking up this Friday. Hey, thank you, Alexis. Happy Friday to you. We almost made it through 2 weeks, guys. Almost did it. Morning, Haber. Morning, Katie. Morning, Sacklin. Almost made it through 2 weeks, people. And then we got one more week, and then spring break, which might suck for a lot of people, but after that, then who knows? Who knows where we'll be at in the world? Just so you guys know, we're gonna, like I said in my calendar, we're gonna go over the College Board, some questions from there. Any questions you guys have, kind of work on them together. So I saw there was like 5 people who started it, so not very many people have looked at it yet. Open that up, and you guys can just start it now. I'm gonna wait like a couple minutes to see if more people kind of funnel in. Morning, Payne. So go ahead and get that open. If you guys want to get started on number 1, get started on number 1. And like I said, in a couple minutes, I'll bring us together and figure out what we want to do. Morning, Josh. Good to see you. So again, guys, if you guys just came in, go ahead and open up your College Board assignment that was assigned yesterday. Maybe take a look at number 1, get started there. That's probably where we'll end up starting. Good morning, Jasmine. So is anyone doing anything over the weekend? Hopefully nothing like, obviously with people, but anyone have anything planned? I don't know, going on a hike in the woods or something, or go in the middle of the lake away from everyone fishing or something like that. Playing video games all weekend, watching movies. Curious to see if anyone has any plans, because I know I don't. Tie-dye everything. Stack, are you just going to go around your room and just grab whatever you can, just tie-dye it? I like that idea. Playing video games, yeah, Katie. What are you playing, Katie? Animal Crossing? That's what everyone keeps talking about. I was thinking about maybe getting a new video game. Figure if this is going to last for a little bit of time, I might as well get started on another new one. And being super bored, yeah, Josh, I feel that. It's like I found myself the other day took a nap just because I was so bored. I wasn't really tired. I just took one because I was bored. Pokemon Sword and Animal Crossing. Yeah, I've heard Pokemon Sword is good too. I just got Doom Eternal. Ooh, Josh, let me know how that is. I was thinking about getting that. That's a good mindless game to play. Like to just like if you just want to go on the video game system and just see chaos like for every second of your day, that's a good game to get. It's really good. Okay, maybe I'll think about getting it. Thank you for the suggestion. I don't think Animal Crossing is my kind of game, but yeah, out of boredom. I saw there was this new like I forget what it was called. Something like with a I played let me think of what the name was. It's like an indie game, but I saw that there's a new one like the next in the series that's out that I kind of wanted to try. It looked kind of fun, but again, if you guys just came in, it looks like I got a couple more viewers. Go to the College Board. You can see I wrote down here number 1. That's the one we'll start with. Feel free. You don't have to listen and do the pace I go at. Feel free to start work on the assignment now. Go ahead and get as much done as you can or what you want to get done. And then for those of you who want to get kind of more guidance going through, I'll do that as well. So you guys this is your decision. You work at your pace. But what I want you guys to do is if you are in here and you haven't started yet, number 1, make an effort at this problem. So I know we just went over this yesterday. I don't expect you to get everything. Try to look back at your notes. I'll give you like 4 minutes. Look back at your notes. See if you can get through like a chunk of this problem. And we'll talk about it in about 4 minutes. Now you can stream video games too. Jasmine, didn't you hear? That's the plan. I'm just trying to use this teaching thing as a vehicle to get subscribers to my new video game channel. But if you guys only give me 1 like every time I stream like I have right now, I don't know if I'm ever going to get there. So you might have to just think to yourselves, am I ruining someone's dream? To be the next big video game streamer? Couldn't be me. Okay, guys, a couple more minutes to work on number 1, and then we'll go over it as a class. There's the likes going up. I wish I didn't have to beg you guys every day. Maybe it's gonna just be like something like like in class every day I would just like you guys would know to get out your open up your calendar and get out your book, all that good stuff. Maybe that's just become like something that's just common. If you enter the stream, just don't even do anything else first. Just smash the like real quick, not the dislike. Okay, I'm talking to you, Stacklin. Stacklin, I imagine everything in your room just being like tie-dyed, like everything you own tie-dyed, and just like lava lamps everywhere, just like completely hippie setup. That's what I'm envisioning when you say tie-dye everything. Like the walls are tie-dye, Your dog is tie-dyed, just everything. I'm tie-dyeing my entire neighborhood. That's what I'm talking about. Changing the world one tie-dye at a time, Stacklin. No remorse. It's like a Dr. Seuss book. All over Million normal, you go down Stacklin Street, just tie-dye everywhere. They'll call you the tie-dye bandit. Okay, let me get started on number 1. So hopefully you had a pretty good start. Either you got through it or you had at least a good beginning steps. So the problem says, it says if dy dx equals y secant squared x, and when y is when x is 0, y equals 5, then what does y equal? All right, so that's what we're working on. What we want to think about is, first of all, like, what do we have going on here? They don't tell us anything about a differential equation. We know it's a differential equation because, well, that's what we're working on. So obviously, I've talked about this before. On a test, you're not going to be told what is going on, what's happening. So since you're not going to be told, you have to figure it out on your own. It's not going to usually tell you use separable equations to solve this. Although it's the assignment, we're not going to be told that. So we have to figure out on our own, what do we do? We want to look at this. We know it's a differential equation because we have a derivative, we have a y, and we have an x. All right, now we actually don't even need all those parts, but what's really important is that we have that derivative. We have the derivative of y and y, and it's telling us to look, based off the derivative, it's telling us to find the original function, y. Okay, and we also have an initial value problem. So we're given the initial value of x is 0, y is 5. So these are the pieces that we're given. We have to decide, okay, how are we going to actually find y? Well, the strategy we have right now is separable equations. So that's what we start with. The first step of separable equations, get y on one side and the x's on the other. So I'm going to divide by y. So I get 1 over y dy. And then I'm going to multiply by dx. So I get secant squared x dx. Again, you're kind of treating dy and dx as variables. Alright, so you divide by y, multiply by dx. So now you guys can see anywhere I see a y, it's on the same side. Anywhere I see x, it's on the same side. I separated those equations. Okay, so now from here, what do we do? Well, from here, what we actually want to find is y. We don't want to find anything with dy, so we don't want any derivatives. So to counteract or to reverse the derivative, we take the integral. So the integral of 1 over y is natural log of y. That was nice and easy. The integral of secant squared is also nice and easy. That's tangent of x. So I end up with natural log of y equals tangent x plus c. Okay, again, taking the integral. So whenever you guys do this, most of the time it's going to be a basic integral like this. So it'll just be like one step. You can just look at it and know. Every once in a while, though, you might have to use u substitution. So we'll see a problem in this College Board where we have to do that later on. But just keep that in mind. Just because it looks messy or you don't know it right off the top of your head doesn't mean to give up. It means that potentially you could use u substitution to solve it. Okay, so now we're here. Again, the whole point of this problem is we want to solve for y. We don't want to solve for anything else. We are given the derivative of y. We want to get back to y. So I need to get y by itself. Well, to do that, I take e as the base of both sides. So if e becomes the base of the left side, I'm left with just y. And if e becomes the base of the right side, I get y equals tangent of x plus c. Okay, and we've talked about this. We talked about this yesterday. We don't want to keep it as this. We don't want that c to be in the numerator, or sorry, be in the exponent. And the reason being is because, like I talked about yesterday, but just as a reminder, I can rewrite e to the tangent of x plus c as e to the tangent of x times e to the c. And because I can write it like that, e to the c is just a constant. That's 2.71 whatever raised to the power of a constant, which is going to be just another constant. So what we do then is we just write that entire term, e to the c, we write the entire term as just one big c. It's one big constant. Okay, now this is useful. All right, we made a really good dent into this problem by getting here. But the question specifically gives us an initial value. This is called an IVP, or an initial value problem, because we're given an initial value. So if we're given an initial value, we got to decide, well, if I use that initial value, I can find what that c is in that particular situation. So I'm just going to draw an arrow up here. We want to look at x equals 0, y equals 5. We want to figure out what c is going to be. So we plug in 5 for y and 0 for x. So instead of y equals ce to the tangent of x, we get 5 equals ce to the tangent of 0. Okay, and we solve this and we just get 5 equals c. Okay, reason being is because e to the tangent of 0. We don't have a calculator on this problem. All right, but if we think of a tangent graph, hopefully we're thinking about, okay, what would that be? We could also think about the fact tangent is sine over cosine. All right, and that's basically 0 over 1 at 0. So that's another way you can look at it if you think about the unit circle. But again, the tangent graph, hopefully we've seen that before, seen it enough where we know that when it's at 0, it's at the origin. So it's right in the center of the origin. So tangent of 0 is 0. E to the 0 is 1. So I'm left just with 5 equals c. Okay, so we're almost done. We got almost the pieces. To put it all together, we replace c with 5. And my final answer is in red here. Y equals 5e to the tangent x. So again, I got this answer from solving c and plugging it back into my original general differential equation, or differential solution, I guess, for the problem. So again, this blue is what we call the general solution. This is the initial value solution in the red, which in this case, the problem was asking for that. So your final answer for that was C. All right, let me know how you guys feel in the chat. Are we good? That makes sense? Any questions? Avery says good. Baron, oh hey Baron, good, good, good. Good, okay. All right. Hi, Braden. Morning. Okay, very good. So let's get started on number 2 then. Let's take a look at that one. So I want to give you guys some time to do it on your own. This is going to be really good practice. See where you're at. If you can do these problems, these are like, I guess, kind of like the foundational separable equation problems. So you're in pretty good standing if you can do these problems without any help. So. And then when you're done, go ahead and type your answer. So just put like if you got like A, B, C, or D, or E. Is there an E? Yeah. So I'll give you guys about, I don't know, 4 or 5 minutes. Just like in class, Alexis and Jasmine, very good. Hey, Andrew. Andrew, if you just got here, we're working on number 2 on the College Board assignment. Okay, looks like a lot of people are getting D. I'll give it about a minute, see other people finish up. Okay, let's get started on this one. All right, so number 2. They give us dy dx is equal to negative 2xy. And then we got y of 1 is equal to 4. So same exact thing as last problem. We want to be thinking to ourselves, okay, we got an initial value, which is y of 1 equals 4. We have a differential equation, dy dx equals negative 2xy, and we're looking for a solution. So putting all those together, our mindset should go immediately to separable equations. So let's separate them. I divide by y again to get rid of that y on the right side, multiply by dx to get x's on one side. I take the integral of both sides, and I get the natural log of y equals negative x squared plus c. All right, and same idea as last problem. I want e to be the base of both sides. So I get y equals e to the negative x squared plus c. And I'm going to take the shortcut here, so I don't have to write that extra step. This just ends up being y equals c e to the negative x squared. Okay, and so now what we want to do is actually solve for c with using our initial conditions. So instead of y, I'm going to put 4 equals c e to the negative x squared. Well, x squared is 1, so negative x squared is negative 1. So I get 4 equals c e to the negative first. Just so you guys know what I'm doing, I'll rewrite the right side as 4 equals c divided by e. So I'm moving that e to the negative first into the denominator. You don't have to do this step if you can recognize it right off the bat, but I'm going to do it anyways. I'm going to multiply both sides by e. So I get 4e equals c. Okay, and I'm going to use that information to get my final answer. So I get y equals, instead of c, I have 4e to the first times e to the negative x squared. Okay, now at this point I'm thinking to myself, okay, maybe that's an answer. So I look at all the solutions, all the options for solutions, and I'm looking, I don't see anything. So I don't see that as an answer. So that makes me think, oh, I got to adjust it. And I kind of look at these solutions A through E. A and B, definitely not. Everything's being multiplied. So my answer, everything's multiplied. So A, B, no way. So then I want to look at C, D, and E. Well, E doesn't have a 4 in it, so E, ignore. So now I'm looking at C and D. And the only difference is just whether it's a positive x squared or a negative x squared. Well, in this case, it's a negative x squared. Right? So D is really my only option. But to show you what we're doing and how that became an answer, if you have two of the same bases being multiplied together, you add their exponents. So e to the first times e to the negative x squared is just e to the 1 minus x squared. Or negative x squared plus 1, however you want to write that. So your final answer then is D. All right, I'll take a second. Any questions you guys have in the chat, go ahead and ask them. Okay, going once, going twice. All right, so what I'm going to do, guys, actually is skip to number 4. So number 3, I think you're going to be all right. Very similar to ones we've been doing. It's not natural log, but it's a problem that I think you guys get the process for to do. Number 4 is a little bit different. So I want to look at number 4. So go ahead, guys, and skip to that one. So we have dy dx equals 2xy divided by x squared plus 1, and we have the initial condition of 0, 1. Oh, pain. Read my mind. All right. So yeah, we're going to do number 4. So I'm going to give you guys, like, again, 3-4 minutes. Type your answer to 4 when you have it. And we'll see how we're doing. If you guys get stuck, also let me know too. So if you don't get an answer or you get stuck at a point, let me know. So if everyone gets stuck, then I know to start. Thank you, Alexis. Stuck, same. Okay, cool. Let's get started then. Okay, so I think actually maybe the harder part of just this problem is the beginning, like what to do at the start. So how do we want to kind of look at this? Well, I can rewrite this fraction to make it a little bit easier if you didn't initially see it. So we got to get this y out of there. So let me just write this as two different functions. One a function of x, and then one a function of y. Okay, so 2x times y, or 2xy divided by x squared plus 1 is equal to 2x over x squared plus 1 times y. Those are the same. All right, so I can divide both sides by y. So I end up getting 1 over y dy equals 2x x squared plus 1 dx. Again, you don't have to write that step, but if you had a hard time finding out what to do at the beginning, it might even help you just to like kind of think of this as just like parentheses around the x squared plus 1, however you wanted to look at it. But that's how we want to start it. Okay, now I have x's and y's all on the same side. And now I got to take integrals. Right, so I'm taking the integral of the left side, integral of the right side. Okay? Integral of the left side ends up just being natural log of y. All right, this is the third example in a row. We're okay with that, hopefully. Now the right side. Do a little arrow here. Some people by this point actually might be able to look at this and have an idea of what it's going to be. Okay, but I completely understand if you don't. Okay, I don't expect you to. What we can decide, though, is that this isn't an identity. This isn't a basic antiderivative. We can't just look at this and say, bam, answer, done. Right? So solving this integral, we have to start being creative. We have to think about, okay, what can I do? Should I do long division? Should I complete the square? What are my options? And I always say you always want to see if you can do use substitution. That should always be the first thing that goes through your head. So I'm looking at this problem and I'm thinking to myself, well, I have a composite function, right? So the denominator, I have a composite function, x squared plus 1. I have it being multiplied by another function, 2x. So I kind of have these pieces that make up a use substitution problem. I also see that there's a difference of 1 power between x squared and 2x. And I know the derivative of x squared is 2x. So like all these pieces hopefully in your heads are clicking. And to solve this integral, you're going to use u substitution. So you're going to let u equal x squared plus 1, which means du equals 2x dx. Okay, which means my new integral becomes 1 over u du. Okay, because du replaces the entire numerator gets replaced with du. Okay, and the entire denominator gets replaced with u. So I get 1 over u times du. Which, hopefully we see that form and are like, yep, I like the sound, the looks of that, and I get natural log of u. Which we know u is equal to x squared plus 1. So that right side integral is equal to the natural log of x squared plus 1. Okay, I'm assuming that's probably the tricky part. That might be the problem, the part that kind of trips some people up. And don't forget we got to add c. So on that right side, well, both sides you have to add c. So just make sure that you remember to do that. And now we go ahead and solve this problem. So looking at this, again, we have natural logs on this side. So in order to get rid of the natural log, to just get y, I want to make e the base of both sides. So I get y equals e to the natural log of x squared plus 1 plus c. Which is equal to e to the natural log of x squared plus 1 is just x squared plus 1. Remember, these are inverses of one another. So I'm left with x squared plus 1. E to the c is just c. So I'm left with y equals x squared plus 1 times c. All right, so now we just got to find what c is. Using my initial conditions of y equals 1, x equals 0, I get 1 equals c. So my final answer becomes y equals x squared plus 1, which is b. Okay, now I went through that pretty quick. Let me know what you guys think. Any comments? Peyton, you messed up there. Yeah, if you guys, wherever you guys messed up, what was the part that tripped you up? I'd like to know. So what made you stuck? Question mark. That's what I want to know. What step was confusing to you guys? The beginning? Okay, so the very beginning. I'm assuming the beginning entails the integral. That's what I'm guessing. Turning the x side into the natural log of it. Okay, gotcha. So the u substitution part, separating the terms. Okay, just separating the terms then too. All right. Yeah, this one it's not too obvious right off the bat. Using u sub. Okay, cool. Very good. So yeah, u substitution, very important skill. Integral part. Okay, cool. Thanks, guys. Appreciate the feedback. So with that being said then, let's do another problem where we can get some more practice with that. So number 5, let's go to that one. So why don't you guys go ahead and get started on number 5. Again, as I've been doing, I'll give you guys some time. Put your answers to 5 in the chat when you get them. I'm not going to give you any sort of guidance for now. I want to see what you guys can do. So go ahead and get started on that one. If you get stuck, let me know. when you guys are done, make sure you put your final answer there in the chat. All right. Looks like a mixed bag. That's good, that's good. About 1 more minute, I'll go over it. Okay, let's look at this one. So, I got a variety of answers. Looks like B, C, and D are the 3 different answers I got. So let's take a look. Okay, so we're given dy dx is equal to sine of x cosine squared of x. And then we got f of pi over 2 is equal to 0. Okay, so at x equals pi over 2, y is 0. All right, and we're looking for the value of y when x is 0. So when x is 0, that's what we're looking for. Okay, so we had a new element that just got introduced in this problem. And that new element is that idea of you're looking for the value of y when x is 0. So we're not thinking of a generic equation or solution anymore. Now we should be getting an exact answer for y. Okay, so everything else is the same process though. So I want to somehow separate any sort of variables. Well, guess what? X's are all on this side. There is no other y's. So all I have is dy equals sine x cosine squared x dx. So I just multiply dx over. Now all the x's are on the one side, all the y's are on the other. If it helps you guys, remember this is really 1 dy. So same process. I'm taking an integral. Well, 1 dy turns into just y. Right? The integral of a constant just gives you the variable you're taking the integration of. So that just becomes y. The integral part's a little tricky. All right, so this is a trig. Hopefully we're looking at this and you're thinking to yourself, okay, what do I have to do or what could I do to solve this? You could try like rewriting something. I mean, you could go ahead and do that. You're not going to get anywhere with it. So it might have taken you down like a little bit of a rabbit hole. You could try, I mean, that's the only really other option you have. And then the only other option is u substitution. So we would try u substitution. You could try letting u equal sine, but when you take the derivative of sine, you get just cosine, not cosine squared. So that's no good. You could let u equal cosine squared, but we don't know the derivative, or we do know the derivative of cosine squared. And we could do that actually, but even easier than all that, why don't we just let u equal just cosine of x? So let u equal cosine of x. All right, so if u is cosine of x, then du is equal to negative sine x, dx. The derivative of cosine is negative sine. Well, we're not looking for negative sine. We're looking for positive sine. We want to use u substitution to get rid of sine x dx. So what we need to do is divide by -1 to get negative du equals sine x dx. Now that might have been the step if you guys got, if you found your answer was D, that might have been the step where you made a mistake. All right, so now I have the pieces I can plug in. So now my new integral becomes the integral of negative u squared du. Because if u is cosine, cosine squared becomes u squared. If sine of x dx is equal to negative du, then sine of x dx equals negative du. And if I'm going to find the integral of that, that's going to turn into negative 1/3 u cubed, which we know is negative 1/3 instead of u cosine of x cubed. Okay, so kind of a lot of steps there. Again, I always break it down into more steps than really needs to be done, but I just want to show you guys the thought process here. So I take that value, that's the entire right side, and then I got to add c. So y ends up being negative 1/3 cosine of x cubed plus c. Continue with the process. I want to use my initial values. So 0 equals negative 1/3 cosine of pi over 2 plus c. Again, using my initial values to find what c is. Cosine of pi over 2 ends up being 0. 0 cubed is 0. 0 times negative 1/3 is 0. So all I'm left with is this entire first part is 0. So I just get 0 equals c. Kind of works for us. Makes me happy. All right, now we're almost done. That means that y is equal to negative 1/3 cosine of x cubed plus 0. So y just equals negative 1/3 cosine of x cubed, which is good, but the question doesn't ask for that. The question asks, what about when x is 0? So we're looking for at x equals 0. We would get y equals negative 1/3 times cosine of 0 is 1. So times 1 cubed. So your final answer just ends up being y equals negative 1/3, which is B. A lot going on in that problem, guys. So take a second, take in what I wrote. Go ahead and chat. Let me know if you have any questions. Braden said good. All right. Can we do 7 before you go? To be honest, Pay, we're not going to be able to get through 7 all the way. It's going to run into Algebra 2. So maybe, I mean, I can try. Yeah, sure, I can try. We're going to have to start right now, though. So let's look at number 7. Number 6 is really quick. Number 6 is like looking at someone's work and saying like, hey, where did you go wrong? So number 6 you guys can get through quickly. Number 7. So number 7, they give us the fact that our solution, so they actually give us the answer here. Y equals plus or minus the square root of x squared plus c. That's the answer to the solution to the differential equation. The differential equation that you started with was dy dx equals x divided by y. I don't know if that ever actually comes into play. I don't think that's going to ever affect us. It says, let y equals f of x be the particular solution to the differential equation with the initial conditions, this is important, f of -5 equals -4. Which of the following is an expression for f of x and its domain? Okay, so if you guys notice, all of my answers, okay, they look very similar to what I started with, what my solution is. All my answers I can pick from look a lot like this. The only difference is there's no longer a c. There is a -9. Okay, so we know then that c is also equal to -9. So we can make that conclusion just based off our answers. We don't even have to do the work to get there. Just based off our answers, we can see c has to be -9. Okay, so the question is which of the following is an expression for f of x and its domain? So there's two different parts, okay? And if you guys look at your answers, big differences, all right? Every answer, the differences are this. Either there's a negative out in front of the square root or a positive, and the domain is either an absolute value or it's not. That's basically the big differences. So we want to figure out this. We want to figure out which one. Is it plus or minus? All right, that's got to be my first step because that'll eliminate two answers if I can determine that. Well, to do that, let's actually look at the only possibility for which one it is. Look at our initial condition. F of -5 equals -4. In order for our y to be, oh, by the way, sorry, this should be equals, shoot, my bad. That should be y equals, not y plus or minus. It should be y equals plus or minus square root of x squared minus 9. I apologize. But if I look at my answer, the only way that y can equal a -4 is if this square root is negative, because I can't take the square root of something and get a negative value. The square root of x squared minus 9 has to be positive, right? Or it wouldn't be on the domain. So the only way that my answer can get a -4 is if I have a negative out in front of the square root. So it has to be negative. All right, so that's going to eliminate B and D. So now our only choices are between C and A. So we just got to figure out the domain. Which will make sense? All right, well, let's look at, let's do C. Let's look at C. The absolute value of x is greater than 3. So we're looking for values where the absolute value of x is greater than 3. Well, we look at some of these values, and these aren't necessarily going to be true, because if you look at anything between -3 and 3, all of those values are all going to be give us not in our domain, because the square root is going to be negative value. So any value between -3 and 3 is going to make this undefined. So based off of that decision, we got to determine then, okay, we could have values that are less than -3 that'll work. So our answer ends up being A. There's not really much work I can do for it, but we want to look for the fact that the values between -3 and 3 will make our answer undefined. Okay? So that's what we want to look for. And that's pretty much the work we need. All right, that'll close off calculus. So everyone in calculus, I hope you guys have a great weekend. You should only have a couple more problems then for this College Board assignment to get finished up. Monday we can go over any questions you guys have on it. Enjoy the weekend, and we'll see you Monday. No problem, Peyton. Thank you, Emma. You too. See you guys. Good morning, everyone in Algebra 2. Hope all is well. Go ahead, guys, while we're getting started, tell me in the chat, what are you guys doing this weekend? Any plans? Social distancing? That's a pretty good plan. Jane said hangman. Yeah, sure. We're going to do a quick Friday hangman. All right, you guys got to give me what you want to do. I need a topic. Yeah, they really can't do much, I understand. But you could always, go for a hike, go fishing by yourself. I don't know. Movies again? All right. Movies. Let's do movies. Trying to think of a good one. All right. All right. So movies. Go ahead and guess some letters. A. No A to start. E. There is an E. I. Oh, guys, I think I spelled this wrong. Hold on. Hold on, guys. Okay, we're back. Apologize for that. Rookie. I don't know. Listen, I'm usually the one guessing. I'm the one who's the professional guesser. I'm not one who creates them usually. Also, I teach math. Like, give me a break. I'm not a speller. You don't have to spell anything in math. It starts with I, Blake. Oh. Yeah, Blake, come on. What a dumb guess. Rookie with an I? What else we got, guys? I need letters. By the way, Tanis is the reigning champ, so see if anyone can take him down. C, good guess. Can we get a studio? I wish. That'd be sick. No, Jay. Hangman Studio. Incredibles. Nope. Not Incredibles. Good guess, though. I really should give you like a hand or something, or an arm for that. It's like we're struggling a little bit today. People. Movie studio. I've always wanted to have like a movie theater set up. You guys ever been to someone's house where they have like a setup in their house that's like a movie theater? It'd be really cool. Got a lot of money for that though. Maybe I'll win the lottery. That's 11 has an R we don't have, and the movie title is The Incredibles. Nope. Not Incredibles. I'll give you a hint. This movie has Leonardo DiCaprio in it. There's your hint. He's the star of the movie. I don't know what studio. I don't know. That's a good question. But Leonardo DiCaprio is an actor in it. He's a famous actor in it. It's kind of a mind thriller. It involves a lot of action. One of my favorite movies ever. R, good guess. But no R. I wonder if you guys have heard of this movie. I gotta imagine you have. Yeah, Chris. Inception. One of my favorite movies ever. Inception. If you guys haven't seen it, I highly recommend it. Pixar made it? Did they? I don't know. I don't usually pay attention to that stuff. All I know is Leonardo DiCaprio's in it. He's fantastic. Oh, you guys watched that for Psych? It's such a good movie. It's one of my favorites. That and another one I really like with him is Shutter Island. That one's like freaky. I watched that for Psych when I was in high school. It's a really good movie though. It makes you think. I like those kind of movies. Because like you don't know what's coming next. Like you're always like you think you know what's going on, and then you find out you're like, oh, I had no clue what was going on the whole time. So what's up, guys? How we doing? If you guys didn't see, I posted the assignment to Google Classroom, so go ahead and get that out. It's under. It should be the first assignment you guys see in your Google Classroom. It's called 7.6 Study Guide. You may be able to get it done in the next 50 minutes, so. Go ahead and get that out. And if you're, while you're not doing anything, if you guys are just waiting for me to start, just go ahead and there's a like button, I guess I've heard about. You can go ahead and like hit it, and it'll give me a like, which will make me feel better about myself. So, feel free doing that if you guys would like. Jaden, can we go over 39 last night's homework? Yes, we can, sir. Let me just get it open. Algebra 2, 3, 27, 20. Number 39. See, Blake, when you say I got you, something tells me that maybe you don't, in fact, have me, and you probably just disliked it. It seems like a crazy move. I don't know for sure. I'm not accusing you, but just want to make sure you're being honest with me. It's the best policy, Blake. You understand. Okay, number 39, Jaden suggested from the homework. This will be good practice for today. So in a couple of years of my book loads, we'll take a look at it. Ouch, no, I liked it. Ah, there you go, Blake. Like I said, I wasn't accusing you. I just, I want to make sure. There we go. Book is loaded. Just got to zoom in a little bit. There we go. Okay. So it says the number n of pet owners in thousands after t years can be modeled by n equals 35 times log, oh my gosh, it zoomed out again, base 4 of t plus 2. Why do they gotta use t's? So stupid. Okay, so they give us that. They give the number of pet owners given by that. T equals 0 is year 2000. Use a change of base format to answer the following questions. Okay, so we want to know for part A. Part A says, how many pet owners were there in 2010? 2010. How many pet owners? Well, this is what we're looking at. N is the number of pet owners. T is the time, where T of 0 equals 2000. So in 2010, we want to figure out what does T equal. Well, if in 2000 T is 0, and 2010, that's 10 years. So T would be 10. Again, this is numbered 39 on page 496. So we're given this word problem, we're given this information. So we end up getting n equals 35 times the quantity log base 4 of, instead of t plus 2, we put 10 plus 2. All right, we just throw that into our calculators, and we get n equals 62,737 owners. Okay, not too bad. That part's just kind of basic understanding a word problem and filling in variables. B gets a little bit more towards the stuff we're doing now. So it says, how long until there are 80,000 pet owners? Well, n represents the number of pet owners. So our equation turns into n equals, instead of n, it's 80,000 equals. And we still have our log, or 35 times log base 4 of t plus 2. All right, guys, so this is our new equation for that. Now, this is going to be good skills, so anyone who's still a little bit confused on this whole change of base idea, this is going to be a pretty, or not, maybe not even the change of base, just logarithms in general, how to rearrange logarithms. This is going to be good help for you guys. Okay, so we're given this situation. Now I'm going to divide by 35. So I get 2,285.714286. Again, I just divided by 35 to get here. The right side has log base 4 of t plus 2 left over. Now I'm going to use change of base. So my base becomes 4 on the left side of the equation, and I'm left with t plus 2 on the right side. So in your calculators, you'll put in 4 to that and see what you get. Oh, I did something wrong. So let's actually back up a little bit. I forgot I didn't read the question correctly. So guys, looking back at the question says the number n of pet owners in thousands. So n is the number of pet owners in thousands. So if I'm doing this problem, right now I put 80,000. Well, that's the number of pet owners, but if we want to represent that in terms of thousands, we want to actually just write that as 80. All right, so it should be 80 equals 35 times log base 4 of t plus 2. And let me just cross all of that out. Let's roll down a little bit. So instead of dividing 80,000 by 35, you divide 80 by 35. And you get 2.286 approximately equals log base 4 of t plus 2. I apologize for that. Now you make 4 by base on the other side. And then you subtract 2. Okay. Jaden, does that help you out? Yep. Okay. So let's look at your homework. So let me actually go to this screen so you guys can see what you should be looking at. So this is going to be your homework, just page 40. So the first part is just practicing using your calculator, just so you guys can get accustomed to using your calculator to express values. And then 7 through 16 is just going to be using or solving equations or inequalities. And so you're going to want to use those notes from yesterday we did. The notes from yesterday will help you guys rearrange these values here. So we're writing every single one of these in a different way so we can solve it. So, yes, only page 40, Jaden. So here's what we're going to do. You guys can work on it. Just treat this like it's like we would in class. If you have questions, you can't raise your hand, but if you have questions, just type in the chat. Let me know. And I will help you out. Again, guys, if you have any questions as you go, just ask. First 1 through 6 is just putting in your calculators, practicing that. So try using it on Desmos and your scientific calculator. And then 7 through 16 require some algebra. Are we eventually going to do page 41 next week or no? Jaden, probably. Actually, no. I don't know, Jaden. My answer is I don't know. I know you're looking for a yes or no, but potentially. Sorry, that's not a great answer. Yes, Chris, the assignment's actually posted to Google Classroom. So you can see on Google Classroom that you will be turning it in. Yes, Jared, it's only assignment today. No lecture, no notes, nothing. Just working on this. Hey, Damon. We talked about one problem from the homework, um, number 39. Other than that, though, we're working on the study guide that I posted to Google Classroom. You're only supposed to do page 40. So we're going to start on page 40, Damon. 1 through 6 is just calculator stuff. The rest, any questions anyone has, I'll go over. All right, Chris. Appreciate the input. I was like, I see people are still here. I just wasn't sure if anyone's like, if maybe people just have it on in the background, and or if everyone's doing all right, or if anyone needs help. I wasn't sure, so I figured I'd ask. Just as a reminder, those of you who are here, I won't be doing a office hour later. I'll answer emails, but I won't be doing a live stream at all. So um, If you guys have emails or questions, go ahead. But if you have questions now, it's a little bit easier for me to answer it like in person. So. Can you do 14? Yeah, sure, Chris. All right. Number 14. So we have 2 to the x plus 5 equals 3 to the x minus 2. Okay, so we want to solve and then round our answer to the nearest 10,000th. Okay, so to start with 14, we can't make these like bases. So we can't recreate these bases so they have the same base. Which is no good for us. So we have to use a different method. And that different method is going to be our what we worked on yesterday, where we can create logarithms on either side. So I'm going to change this as log of 2 to the x plus 5 equals log of 3 to the x minus 2. So basically you're taking the log of both sides. Now using my power rule, or power property, I can rewrite this as x plus 5 times log of 2 equals x minus 2 times log of 3. Okay, and so now our calculator is going to be pretty important to us. So what we want to do is, let me actually just write it like this. I'm going to distribute that log to both of these, to x and to 5, to x and to negative 2. So I'm going to get x log of 2 plus 5 log of 2 equals x log of 3 minus 2 log of 3. So Chris, the reason I'm doing that is because I want to be able to combine like terms. So my best way to do that is to actually factor or to distribute those. And now let's get x's on one side and logs on the other. So I get x log 2 minus x log 3 equals, now in my calculator I'm going to take negative 2 log 3 minus 5 log of 2. So in my calculator, I'm going to put that. Okay. And I end up getting approximately negative 2.4. We'll just round it to hundredths. So let's do negative 2.46. On the left side, I can factor out an x. So if you factor out an x, you're left with log of 2 minus log of 3. Okay, and then you want to divide everything by log of 2 minus log of 3. So I get x equals, in my calculator, I'm going to take negative 2.46 divided by log of 2 minus log of 3. So that's what it'll look like on your screen. And you get approximately 13.97. An approximation, not exact, but that's my approximation. All right. So kind of a lot of work there. Can we do 7 and 9? Yeah, hold on a second, Chris. Yeah, no problem, Chris. We can do that. Okay, so you said you want to do 7 and 9. All right, let's look at 7 real quick. So 4 to the 3x equals 12. Make sure you can see. Okay, so again, make sure you got to check to see if you can just make this easier and just make the common base. So give them a common base. We can't. The only one that would work would be 2, but 2 doesn't go into 12. Well, it does go into 12, but you can't square it or cube it to get 12. So our only option then is to take log of both sides. So you get log of 4 to the 3x equals log of 12. Use the power property. So I get 3x log of 4 equals log of 12. I'm going to divide both sides by log of 4. So I get log of 12 divided by log of 4. So I get 3x equals 1.792. Divide that by 3, and I get x equals 0.597, approximately. Oh, and it says round your answer to the nearest 10,000. Sorry, I didn't realize that. So it would be 7.5. And your answer for 14 would be actually 13.9666. Sorry about that. Okay, then you said also you want to do number 9. Oh, number 9 is going to be the exact same thing, just different numbers. So let's see. So we have 5 to the 4x minus 2 equals 120. We want to take the log of both sides. We want to use the power property. We want to divide by log of 5. So I get 4x minus 2 equals log of 120 divided by log of 5. You want to add 2 to both sides. So I get the 4x by itself. I'm going to put that all in my calculator. So I'm going to get log of 120 divided by log of 5 plus 2. And then divide that value by 4. And you get x equals 1.2437 as your final answer. All right, so that's 7 and 9. Yeah, no problem, Chris. Hope that helped. All right, guys. I don't know if anyone's still listening or hearing. I'm gonna take off. Hope you all have a great rest of your weekend. I will see you Monday. Like I said, make sure you're looking at the calendar, checking for updates. Next week might be a little bit different how things are organized. So just make sure you guys are on top of that. Have a great weekend. I'll see you Monday.